Hello everyone, I am Ankit Mondal and this is my ELP lab project, Transformers in Household Appliances. Specifically, we will be seeing how it is being used in mobile phone chargers. Now, why do we need transformers? Well, we see transformers are used in supply lines to step down voltages, and they are big transformers. But you'll be surprised to know that transformers are also being used in our own homes. In fact, if you think about it, the input mains is at 220 volts. And the devices we use, like the LED lights, doorbells, mobile phones, while charging, they require much smaller voltage in the 5 to 10 volt range. But how is this 220 volt input being converted into 5 volt? Well, the answer is simple, and it is that a transformer is being used. In fact, if you see the mobile phone chargers, you will always find a rating like this. And this rating is nothing but an indication of the transformer that is being used in these kind of devices. Well, we have seen in our lab classes how a transformer works, how it can be used to step down voltages. We know the relation that Vp by Vs is equals to Np by Ns. And this is an equivalent circuit of the transformer. These are the impedances referred to the high voltage side and can be calculated using the various tests that as we saw in the lab test. But now let's return back to our topic of the project, which is how can these transformers be used in a mobile phone charger. First, let us understand what a mobile phone charger does. A mobile phone charger is supposed to take the 220 volt AC input and convert it into a 5 volt constant DC output. But in order to do this, it first has a duty to convert the AC input into a low voltage AC output. For example, it will convert the AC input to 20 volts to AC signal of 9 volts. Then a full wave rectifier can be used to convert this AC signal of 9 volts to a DC signal of 9 volts. And finally, a voltage clipper or a regulator can be used to convert this to a constant DC output of 5 volts. In fact, now we can see the circuit of the mobile phone charger. Over here, as you can see, the transformer is one of the most important components of the circuit. There is an input of 220 volts and the output, which is expected to be 9 volt, will be fed to the rectifier circuit, which will then convert it into a DC signal of 5 volts. Now, the transformer being used here is a special kind of transformer known as a center tap transformer. The specialty being that at the center, it is tapped to the ground. So the voltage here is 0 volt. Now, suppose if the voltage being developed across the two terminals of the secondary is 18 volts, then since the middle is at 0 volt, then the upper terminal A will be at plus 9 volts and the lower terminal B will be at minus 9 volts. Now, some other specifications of this transformer is that its input is at 220 volts, output is at 9 volts, as we already told you. The output current is expected to be at 5 ampere. It is used generally in vertical mount configuration and it uses a soft iron core, which is to reduce the hysteresis losses. And since the output is of 9 volt, this is also known as a 909 transformer. From the turns ratio relations, we can actually calculate the turns ratio of this transformer, which will come out to be 110 by 9. So now we have understood that we need a transformer of 110 by 9 turns ratio in order to convert the 220 volt input into a 9 volt output. And this can be done using a center tap transformer. Now, since we are looking at this application, let's also look at how the rest of the circuit works. The 9 volt AC signal is now fed to a rectifier circuit, which converts this into a time varying DC signal. Then a capacitor is used, which smoothens out the signal to form this wavy kind of waveform, which is almost constant, but not exactly constant. In order to make it exactly constant, we use a voltage clipper, which clips the voltage at a lower level like this, and thus we get a voltage output of 5 volt. It is important to understand that a transformer needs to be used here. We cannot directly use a clipper because the voltage output of the that is being fed to our mains is at 220 volts, and such a high voltage may cause the breakdown of the diodes being used in the clippers and other semiconductor devices. So for this reason, a transformer is required to step down the 220 volt input to a 9 volt input. Then we can process the signal and create the required output signal. Thus, we have understood that the transformer is one of the most important parts of the mobile phone charger. In fact, in today's devices, some ferrites or material are being used which have low coercivity. Thus, the hysteresis loss will be less. We can also use high frequency signals now, which will help in increasing the power to size ratio, thus resulting in the small yet powerful chargers that we use today. I hope that I have been able to clearly explain how transformers are such an important part of the mobile phone chargers, and in fact of the many small devices that we use in our house every day, and that transformers are an integral part of our daily electrical appliance usage. Thank you.